So thanks, sorry for the technical issues. Teams just chose that moment, the worst possible moment. So I'm presenting the card on storms and waves changes around the UK and Ireland, and with lots of contributions from my co-authors. So I'm really happy to see both Piali and David are here on the call today. So I'd like to thank everyone for their input, which has been very helpful. So taking over from David, who was leading it on the last time around. And it's been great to have all the foundations that he's done. So this is an iteration on that with a few new data sets to talk about and some useful like meta-analysis. So we'll start by just a summary of the bit of a graphical abstract to show what's going on, to understand that what's causing these changes in winds and wave patterns. The waves are rather passive, so that everything that we've seen, the changes in ocean circulation and temperature, are really driving these atmospheric patterns that drive the waves. So they're quite at like the bottom of the chain. And these waves and storms contribute to extreme water levels around the coast, and rough seas, which can be important for for shipping and also erosion. Most of our winter waves are during the autumn and winter time, and they can cause a lot of damage, especially to offshore constructions. And it's important for operational conditions as well. We have got some evidence that the waves are changing, and future climate change may accelerate these patterns, which is important because they're important for flood risk assessment and shoreline erosion. So the changes in the waves are pretty strong, pretty closely linked to changes in atmospheric conditions and storminess. So what's been happening in recent decades is driven by the large-scale oscillations like the North Atlantic Oscillation and the Weeper Oscillation. So there's been a poleward shift in the storm track, which is really controlling the UK's waves since the 90s. And we've got an increase in the number of these larger storms. Put that in the context of a reducing mean. So we've got two kind of important trends going on. So the mean has been dropping, but we're seeing more of these more intense storms contributing to larger extreme wave heights. But it's very difficult to see any climate change signal in these. So there are trends, small trends in the mean and the extreme, but it's very hard to pick out the natural variability to get any climate change signal. So even though we've got a growing a range of data sets and longer period data sets, it's still hard to get a trend. Depending on which period you choose, you can get slightly different trends identified in the storminess and the waves. So though the wave models are pretty good, we believe that they are representing the real systems. It's the driving inputs of the storms and the waves and the winds that are leading to our poor understanding and confidence in the wave projections. So if we have a look at some data, there's been growing data sets from the satellite and model reanalysis. So this is a couple of plots of the changes. So this is the trends in winter waves over the North Atlantic, and the top two are satellite data sets that have been binned, and the bottom two are model reanalysis. So there is some consistency between the model and the observations, which is reassuring. That we do see this changing trends of the order of a couple of centimetres per year. Put this into the context of mean wave heights of 3 or 4 metres in these areas. So these are still relatively small changes, but it does look like we're seeing a reduction in those mean winter wave heights to the north of the UK and an increase in the south. So there's robust trends. So I should also say that you might see some dots on here, and that's where there's consensus. So between these data sets, the fact that you can't see many dots is linked to the uncertainty that there's a lack of this robust trend, and that's down largely to these interannual and decadal variabilities, long-term variabilities. So in that context, there's also been some work to look at how these wave trends might change in the future. So there has been a lot of new data sets come out recently. So there's a CMIP6, but there's also been a meta-analysis of global wave models called CowClip. So this is the Coordinated Ocean Wave Intercomparison Model project. And that's been really useful to try and get some sense out of the different variability of structural uncertainty in the wave models and uncertainty around these different climate model behaviours. And there is some consensus that we are seeing changes in the North Atlantic, but it's hard to get it out of the natural variability. the trends are to an increase in the most severe waves, so the largest sort of 90th, 96th percentiles, significant wave height do seem to be increasing together with the number of rough days. But there's a reduction in that mean associated with it. So we're seeing a sort of change in this density function, that they're getting a longer tail, but a reduction in that mean. And we're also seeing an indication that we're getting more storms more intensely during the winter time. So just to put this into context and try and get a bit of a spatial map of it, this is the kind of typical conditions that we're seeing this is the mean on the left, and the mean annual maximum on the right is just a measure of extreme waves. So this is some recent results from the UK climate predictions, UKCP 2018, where we did some model downscaling to try and get a high resolution picture of what these future waves are going to look like, as well as the meta-analysis that I showed you with horse global models. And we see quite robust, so where there's no shading, we have confidence that this is an emergent signal. So the mean is on the left and the mean annual maximum on the right. So we see this reduction in the mean wave height, which we have quite a lot of confidence in pretty much everywhere. There's a slight increase to the north, which is thought to be due to receding sea ice. So when you've got that Arctic sea ice dropping back, you've got an increased fetch, so you can get larger waves coming in from the north. Whereas the change in the mean annual maxima is quite a lot more uncertain, so there's a lot of shading in here. But we do observe changes which are, can be of the order 0.5 metre to even 1 metre in places, and with a trend towards more increasing larger extreme waves. I'll go on to the confidence assessment. So even though we've got this growing body of evidence, where from satellites, from model reanalysis, from longer voice sets, there's still not a lot of consensus between those observations and the models, and that's largely down to the interannual variability. There is some inconsistency about how these things are measured, and what we're seeing based on how the surface roughness is included. So there's hope from this with lots of new instruments. So the SWAT satellite was launched at the end of last year, which will give some really nice sea state data. Whereas what could happen in the future, our confidence is still super low in this, because though there is some consensus between the climate models, the sensitivity of the waves is down to what's happening in the atmosphere and these storm tracks. There has been improvement in the position of the storm track in the CMIP6 models. So we're getting there, but they're not able to resolve these really deep systems and the intense waves associated with those high winds. I want to go on to the sort of challenges and the emerging issues. So I've mentioned the inconsistency a couple of times, and the problems of getting these storms well resolved in the climate models. But there's more understanding required about how these storms are working, and understanding these long-term decadal variabilities in the North Atlantic and how they respond to what we've seen about this circulation and ocean temperature changes. There is, it's probably worth saying a little bit about how waves interact with other processes, because one important consideration is how the uncertain changes in the waves will interact with the change in sea level. So, we've got pretty good certainty about the rates and locations of that sea level rise. And it's well known that if you've got a rising sea level with the same sort of wave or even storm surge coming in with it, you will see those large waves reaching the coast more frequently. So it's about how these frequent waves, even if that storminess itself is not changing, combined with the background of sea level rise, we'll see impacts of those same waves at the coast more and more frequently. So that's worth mentioning as well. And there's a little bit more on the report about the use of new techniques, so how we can get the best out of these models by using meta-analysis and lots of statistical methods to try and dig into these nice big data sets to reduce this future uncertainty in the context of the historic variability. So there's a need for better understanding of the storm systems, and then how the waves are a great integrator of these small changes in the atmosphere, and it may be able to see a more emergent signal from things like the long swell waves, rather than just looking at the local wind changes. That's all I've got. I had a question come in on the email, which I can answer at the end as well.